Okay, baik. Assalamualaikum warahmatullahi wabarakatuh. So we are in the chapter 2 of the operation research. The chapter 2 consists of the queuing analysis, or if you refer some book, they are mentioned about the queuing system. So what is a queuing? What is a queuing? Right. So queuing is a waiting. So if you learn in quality engineering under the chapter of lean manufacturing, so the waste, texture or not, has been defined 7 type of waste. The one of the waste is wetting. So wetting is a waste. So we need to pay some time, the time of the wetting. So in a manufacturing, as a manufacturing engineer, you must know how to eliminate the waste. But before you eliminate the waste, we need to define how long we need to wait. Okay, so that's why we have this chapter. So chapter 2 is queuing analysis. So under this chapter 2, we will define the problem. We will collect the data. We will formulate the mathematical equation and deriving the solution. Then we will calculate what is the waiting time. Okay, for example, in manufacturing, in the production floor, what you can see is sometimes a part waiting to loading into the machine. In production, they call it WIP, work in progress, or they call it inventory. So that means this is the waiting. This is the queuing system. So that's why we need this chapter. Okay. Alright. So the learning objective of this chapter is to understand the key element and underlying the mathematical concept of analytical queuing system. So in this chapter, actually, we use uh, statistical analysis, which is the probability. Okay, the probability. So every question, every situation will convert into the probability. So how to convert into the probability? For example, we will calculate the arrival distribution, the arrival rate, the service time distribution, okay, and queuing discipline and behavior. So we have five theories in this chapter. Okay, so I need about 2 weeks to complete this chapter. So we'll convert the situation into the arrival rate. Arrival, the symbol of the arrival is a lambda. The service rate will convert, the symbol is a mu. Okay, so queuing system you can see anywhere. You can see in the ATM, you can see in a petrol pump, you can see in the plaza toll. So in every destination, you can see the queue. That's mean that is using a queuing system. Okay, to understand the single, so for this program, we just focus on the single server queuing line. And some situation we use multiple servers queuing model. Okay, so this system will be applied to the operating characteristic formula. We use some formula. We have about 7 formula in each category. So we have 5 type of a queuing system. So each type of queuing system we have about 7 formula. So that means we will have 35 formula or 35 equation to solve the problem. Okay, so to be able to apply the operating characteristic formula or equation for the multiple server queuing system, we have a single, we have a multiple. To understand the economic trade-off and to appreciate the importance of underlying psychology of the waiting design managing queuing system in practical business situation. Okay, so what is a queuing system? What is a queuing analysis? So queuing analysis is one of the most important tools for the involved with the computer network analysis, waiting the call, waiting something, with whatever related with the waiting considered as a queuing analysis, you can use that approximately answer. That's why I said approximately answer. When the approximately answer, that's mean the probability, kebarangkalian. Okay, how many lines should be time sharing system in the dial rotary, for example? How much terminal need to need for the inquiry center, for example? How many counter need to open in supermarket? How many counter need to open in a banker? How many counter need to open into government agency, for example JPJ? So how many counter need to open for the touch and go? How many pump need to install in the pump station? So that is the queuing system. Okay. Then queuing analysis, we have many cases when the important variable project the effect some changes of design. So either the load of the system expected to increase the design change the contemplated. So in the performance interactive real-time application, often the parameter is concerned of the response time. So we need to improve the response time. So in other cases, throughput the principal issue. In case of the projection and performance are to be made, basis existing information, basis estimated load for the new environment. So is this example. So the response time, we expected the response time, but we receive actual time. So what is the gap? What is the gap here? So this is the gap. The gap is a waiting time. Okay, for example, in restaurant, you order nasi goreng, for example. How long do you need to wait? 2 hours, 3 hours. Okay, so this is the waiting time. So we need to eliminate. We want to eliminate this waiting time. Or if we cannot eliminate, we want to minimize the waiting time. So this is the concept of the JIT, just-in-time production system, introduced by Toyota. Okay, so we have 5 models. I mentioned to you we have 5 models, so 5 theories. So the first one is the basic single server waiting line system. Second, undefined and constant service time. Third, finite queuing length. Fourth, finite calling population. And fifth is multiple server waiting line. So we have a counter. So whatever situation, this is we call it counter. Okay, in finance they have how many counter? They have 2 counter, 3 counters. So this is the counter. Okay, so you have a waiting line. Okay, so this is considered as a queuing system. Okay, if machine considered as a counter. Okay, so we have 5 categories, 5 theories of the queuing model. So 1 to 4 is a basic, is considered as a single server. But some situation we have a multiple servers waiting line. So how the multiple server look like? So we have a 2 and more server, but we have a single line to wait before enter into the counter. Okay, so either counter 1 or either counter 2. Okay, if let's say we have a 2 machine in production, we have a 2 machine, but we have a single line waiting to be processed. So that is the single server waiting line. So in this chapter, we will cover all these subchapters. The basic single server waiting line, the undefined or constant service time, finite queuing length, finite calling population, or multiple server waiting line. So this is, we call it the behavior of the theory system. So what is the input for all these things? Okay, the 2 input, the most important thing is the service rate, mu and lambda, the arrival rate. So how to calculate both? We can see one by one, don't worry. Alright. So the single server queuing line, we have, for example, as I mentioned to you, we have 1 server. We have a multiple queuing line. we have a queue line. So here each customer, each product waiting to be served. So this is considered as an inventory or work in progress. Okay, so in every time, every minute, every hour, customer will be arrived or product will be arrived, we will convert into the lambda or arrival rate. Same thing, we will have a service time. So when we have a service time, we need to convert into the mu. So what is a mu? So if you realize here, mentioned about the rate, the arrival rate. So what is the rate? Okay, that lambda and mu will convert into the hourly rate, rate per hour. Okay, for example, if customer arrive every hour, every 30 minutes. Okay, if customer arrive every 30 minutes, so the lambda, the arrival rate is a 2. How I get 2? Okay, how I get 2? 60 minutes, 1 hour, 60 minutes divided by 30 because every customer arrive 30 minutes. So 60 minutes divided by 30, so the lambda is a 2. Same thing for the mu, the service time. If a server can produce every 20 minutes, what is a mu? Okay, mu means the service rate per hour. So if let's say the server able to produce every 20 minutes, so the mu is a 3. How I get 3? 60 minutes divided by 20. Okay, so this is lambda and mu. So as I mentioned to you, we will have 5 categories, 5 theories. So the 5 theory is based on the must have a waiting line, pattern of arrival, service time, the queue discipline first come first serve, and no barking or reneging. Okay, and this is example in the ATM. Okay, so this is example in the grocery shop, in the supermarket. So you have a waiting. So that is considered as a queuing system. Okay, this is about the introduction of the queuing system. So before that, we have, as I mentioned to you, we have a arrival rate, we have a service rate. So arrival rate, the symbol is a lambda. So service rate, the symbol is a mu. Okay, that both lambda and mu calculate based on the rate per hour. Your answer must have a no symbol. This is the rate. If let's say service time 20 minutes, the symbol, the unit is a minute, so that means this is not a rate. This is the time. Okay, you need to convert to the arrival rate. Okay, so this is about the fundamental or the basic, the theoretical about the queuing system. From next video, I will share with you for every model or every theory to complete this chapter. And that's all about the introduction of the queuing system theory. Thank you very much. See you again, and Assalamualaikum warahmatullahi wabarakatuh.